Welcome to lesson 95. Today we're talking about volume of right solids. And as we look at right solids, we're looking at basically different types of prisms and how to apply these prisms so that we can solve for, well, you guessed it, the volume. Right? Now, to find volume, in front of you, I've given you a new formula. And even though this formula looks a little different, it's actually a formula you've been using for a long time when it comes to volume. Now, volume often has to deal with, in the past you've dealt with rectangular prisms or a cube, something like that. And the first thing we want to look at is the fact that this formula actually has a lot to do with the same thing. But the benefits of this formula is it can be applied to any prism and also cylinders. But let's talk about that. Volume, in the past, we've always called it length times width times height. And that is very true. And that formula helps us understand the concept here. Now, what we want to look at real quickly is this right here. The length times width. Length times width. When you hear something equals length times width, suddenly a new idea or a review idea pops in your head. You know that length times width is also a formula, and that allows you to find the area of a rectangle. Now this is where our principle comes in here, because we have this large B. And this large B happens to deal with the base of a right solid, but it doesn't stand for the base like the base of a triangle or the base of a parallelogram. Instead, this big B happens to stand for, big B equals the area of the base of your shape. Now, what does that mean? If I look at this in conjunction to this right here, I see that if I had a length of 10, I don't know if you can see that, length of 10, right, that would be this length right here. And the width of the top face would be this distance right here. So if I say 5, it would be 5 times 10. And so my length is 10 and my width is 5. 10 times 5. And what I've really just solved for there by multiplying those two things is I've solved for this entire area. And so what I've really solved in length times width is I've found the area of one of the bases of my prism. By finding the area of the base of this prism, I can now multiply by the height and get a correct volume that we're doing here. And that's the principle we're going to apply as we work through this concept, is the fact that we're going to use big B, which means area of the base. So we got to remember our area formulas and then multiply by the height of our right solid. And by doing that, we can find the volume of any right solid. Let's try this out. So our first example says find the volume of this prism. Right, so this is a right triangle. Two right triangles joined together. Two right triangles joined together means we have a right triangle, triangular prism, and we can follow our formula. So V equals the area of the base times the height. Okay, so let's figure this out. First of all, we have to understand what is the formula for area of base in this case. Now our base happens to be this beautiful little right triangle. So our right triangle is what we need to solve for. So we have to solve for the area of the triangle. Well, area of a triangle, you're saying, okay, what's the formula? What's the formula? What's the formula? That would be 1/2 base of the triangle times the height of the triangle. So our base of our triangle is 4. The height of our triangle is 3. So we would go 1/2. That says third. Why did I write that? 1/2 times the base of 4 times the height of 3. So that would be my first thing. So 1/2 times 4 is 2, because half of 4 is 2, and 2 times 3 is 6. And so the area of my triangle is 6, which means that this B, the area of my triangular base, is 6. So now my formula looks like this so far. 6 times the height now. Now the height, of course, in this formula refers to the height of the prism. So the distance connecting one base, this triangle, to our green triangle over here, which of course is going to be 11 centimeters. So right now we already have an area of 6 centimeters squared, and now we're going to multiply by 11 centimeters squared, and 11 times 6 is 66. And because it's centimeters squared times centimeters, because it's volume, we're going to end up with a cubed root. And so we have 66 centimeters cubed. So you can see we broke down our base into the formula that fit with the base of the prism, and then we multiplied by the height of the prism to be able to solve this problem. All right, what about this one? All right, our cylinder here it's kind of it's a prism in a sense, because we have two bases that are circles. Let's just write cylinder. Cylinder. Now we can't read either of them. We got two bases though, right? We can still use this formula. Volume equals the area of the base times the height. We already see the height here. It's given to us, right? 15. So now we got to find, what in the world? 15 centimeters. So now we got to find the base. So the first thing we want to do is write big B, which means area. If we don't remember area of the base of the prism. The base of this prism, or the base of this cylinder, of course, is a circle. So we need the formula for the area of a circle. Area of a circle is pi r squared. Well, we're in luck here because we're given a radius of 8 centimeters. So that means pi 8 squared. Pi times 8 squared. So 8 squared is 64. And now we're going to multiply by pi to give us our area of the circle. So the area of the circle, of course, is going to be 64 times 3.14, which gives us the fast answer, 290.96. So now we're going to take this 296, because that's our area. That stands for our B. So then we have to multiply by the height of our cylinder, which is going to be 15. So then we multiply by 15, and we get an answer of 3,114.4 centimeters cubed. And so we have that as an example. Right? So to solve these problems, what we need to do is we got to take our formula of volume equals base times height. Understand that the big B stands for area of the base, so the base of the prism. So we got to transfer it into the formula that fits, whether it's a circle, whether it's a triangle, whether it's a rectangle. We find the area. Once we found the area of that shape, then we're going to multiply by the height of the prism, or of the cylinder, which is always that length that connects one base to the other base, just like here, right? Base to base, and so forth. And in the end, we come away with the volume of those shapes. So let's take it one step up. You got two shapes here, all the information that you need. Find the volume of the shed. Okay. So first find the volume of your pure triangular prism top, and then find the volume of your rectangular prism base, and add them together. Oh, you knew that. I'm sorry. Do the work. See you in class. 95. Boom.